The first thing I'm going to do here is add a few more vectors to the diagram. Because I'm told that OPQR is a rectangle, I know that if this is the vector 3b, then from P to Q, that must also be the vector 3b. From O to D is the vector A, as we're told here, and we're also told that D is on the point OP, such that OD is a third of OP. So the distance from here to here is 1/3 of the distance all the way across. In other words, all the way from O to P must be 3 times the vector A. I'll put it out here, which means that this little bit from D to P must be 2A. And again, because I've got a rectangle here, I'm going to fill in this vector here, which is the same as this one. In other words, it's also the vector 3A. Okay, let's have a look at what we need to do. First thing we need to do is find the vector OQ. I'll put it over here so that we can see the diagram, but this is part A. So the vector OQ, well, I can see that to get from O to Q, I could go from O to R first, and then I could go from R to Q. Okay, I could also go from O to P and then go from P to Q. It actually doesn't make any difference. If I go from O to R, that's the vector 3b, and then I add this vector here, which is 3a. If I go the other way, so O to P first, that's 3a, and then I follow that with 3b, and then which means that I add 3b. Either way, I get the answer 3a plus 3b. So the vector OQ, and I'm going to write it in alphabetical order, easier, 3a plus 3b. Okay, part B asks me to find the vector OE. So I'm looking for this vector here. What I'm told, though, in the question is that OE is 2/3 of OQ. They give me that here. So OE is 2/3 of OQ. And it just so happens in part A that I've found the vector OQ. In other words, I'm going to find 2/3 of the vector 3a plus 3b. If I multiply 2/3 by 3, or find 2/3 of 3, that just gives me 2. So the vector comes out as 2a plus 2b. Okay, so the vector OE now is 2a plus 2b. It helps to remember what you've actually got, what you've actually found. Right, part C. Oops, sorry, no, that was II, and this is now III. Okay, we are now asked to find the vector DE. So let's have a look at how we could find DE, and it really helps to think about what you've already found. So I've already found OQ, and I've found OE, and it looks as though OE is going to be quite useful, because to find DE, which takes me from here to here, if I go from D to O and then OE, I can use the OE that I've just found. So I'm going to do DE by going first of all from D to O, so the vector DO, followed by the vector OE, which I've just found. Now the vector DO, well, we can see that OD is the vector A, so to go in reverse, DO is just going to be minus A in the opposite direction. And we're now going to add OE, which we have here, so that's 2A plus 2B. And if I simplify that, minus A plus 2A, well, that's just A, and that's A plus 2B. So we've now found the vector DE. Right, the next part of the question asks us to show, using a vector method, that DEF is a straight line. Now I can spot from part 3 here that I've already found the vector DE. So I already know, oops, that wasn't very straight. I've already found the vector that takes me from D to E. Let's use a line instead, might make it a bit neater. So we've found this one here. So what I'm going to do now is think about how I could get to F. And in fact, I'm going to find the vector DF. I know DP. I'm now going to find the vector that takes me from P to F. So it's this little bit here that I'm concerned about. But if I look back at the question, what I will see is that I've got a bit more information here. QF, the vector that takes me from Q to F, and it tells me that PQF is a straight line, so this continues as a nice straight line. QF is a third of PQ. Now, the vector PQ is 3b, and if QF is a third of that, or 1/3 of 3b, is just B. So this little bit here is just B, which means that all the way from P up here to F, this vector here, the vector PF, is 3B plus B, which is actually 4B. Okay, it's a bit of a mess, so I'm going to just rub that out and sort of put it on a bit more neatly. So the vector that takes me from from P to F, this one here is the vector 4B. Let's make that a bit thinner so I can do a bit more writing. Okay, let's have a look then what I can do now, because I can now find quite easily the vector that takes me from D all the way up to F. So let's find the vector df, and I can see that df is just going to be dp. I'll think what that is in a minute. So dp plus that pf. Now I've rubbed this out, but actually that was the vector 2a. So dp was 2a, and then pf is 4b. So df is the same as 2a plus 4b. Okay, let's just summarize what we've got then. So df is the same as, so we know that df is the same as 2a plus 4b. And I'm just going to factorize that because I can see that it factorizes quite nicely. I'm going to take out the 2, and then it becomes a plus 2b. And actually, I've pretty well finished now, because if I now look back over here, that vector a plus 2b is actually de. In other words, stick the 2 in there, I can see that df, the vector from d to f, is 2 times the vector from d to e. So let's just have a look at what that means diagrammatically. So the vector from d to f up here, this vector is twice this vector. And because both of those vectors start at the point DE, so we've got 2 parallel vectors which both start from point D, it must mean that DEF is a straight line. So to explain that in words, I would say, well, we've got the fact that DF is equal to 2DE, so the lengths are doubled, and also DF and DE must be parallel. If DF and DE are parallel, it doesn't necessarily prove you've got the same line, but they both pass through the point D. And if you've got 2 parallel lines, so you've got one line which is DF and you've got another line which is DE, and if they are parallel to each other, well, the only way that that can be possible, for 2 lines to be parallel and both pass through point D, you can't have 2 point Ds. The only way for that to be true is if DF is actually on the same line. In other words, DEF must be a straight line.